Okay. Hello everyone. Welcome to Q Physics Academy. So, for electrostatics and magnetostatics का जो लेक्चर्स हम लोगों ने स्टार्ट किया था उस लगभग हम लोग लेक्चर नंबर 18 में आ गया. ठीक है, जो लेक्चर नंबर 18 है उस लेक्चर नंबर 18 में हम लोग डिस्कस करने वाले. दिस इज बेसिकली लेक्चर नंबर 18. ओके, इस लेक्चर नंबर 18 में हम लोग डिस्कस करने वाले बहुत ही इंपॉर्टेंट टॉपिक दैट इज मेथड ऑफ इमेज. ओके, मेथड ऑफ इमेज, इसके ऊपर थोड़ा बहुत हम लोग डिस्कस करेंगे. और ये हमारे लेक्चर्स जो लोग B.Sc फिज़िक्स ऑनर्स के कोर्स में है सेमिस्टर 3 का, ठीक है, सेमिस्टर 3, उसके लिए भी इम्पॉर्टेंट है. ऑल्सो दिस लेक्चर्स इज वेरी इम्पॉर्टेंट फॉर दो स्टूडेंट्स who are preparing for IIT JAM, JEST, TIFR, CSIR NET, etc. And this is the part 1 basically. Okay, this is part 1 lectures. So in this part 1 lectures I will discuss some basic theory part, and in the next lectures in part 2 I discuss some university related questions, and then in part 3 I will try to explain some important and conceptual questions of the previous year questions paper like TIFR, JEST, IIT JAM, CSIR NET, GATE, etc. Okay, so now let's start here the method of image lectures here. तो हम लोग वन बाय वन एकदम बेसिक से स्टार्ट करेंगे. देखो, मेथड ऑफ इमेज का क्लास हम लोग सीखेंगे कैसे, क्या क्यों मेथड ऑफ इमेज पढ़ना है, उसमें क्या क्या पढ़ना है, उससे उस मेथड ऑफ इमेज के थ्रू हम लोग क्या क्या बेसिकली कैलकुलेट कर सकते, इस तरह के हम लोग कैलकुलेट करेंगे. आराम से हम लोग एक एक चीज़ को स्टडी करेंगे. ओके ओके, सो फर्स्ट ऑफ ऑल मेथड ऑफ इमेज. ठीक है, इस मेथड ऑफ इमेज में हम लोग क्या क्या पढ़ने वाले हैं. देखिए, मेथड ऑफ इमेज का क्लास में हम लोग पढ़ने वाले एन अर्थ इनफाइनाइट कॉन्डक्टिंग प्लेन एंड ए पॉइंट चार्ज. तो आप फिगर नंबर 1 को देख लीजिए. जो फिगर नंबर 1 है, इस फिगर नंबर 1 में एक प्लेन है, इनफाइनाइट कॉन्डक्टिंग प्लेन है. इस कॉन्डक्टिंग प्लेन के ऊपर एक पॉइंट चार्ज Q एट फाइनाइट डिस्टेंस D में है. तो इसके लिए हम लोग स्टडी करेंगे मेथड ऑफ इमेज. इस तरह का केस के लिए मेथड ऑफ इमेज का कंसेप्ट. ठीक है, और सेकेंड केस में देखिए ग्राउंडेड एक स्पेरिकल कंडक्टर है. ठीक है, ग्राउंडेड स्पेरिकल कंडक्टर है. तो इसमें भी हम लोग एक ग्राउंडेड स्पेरिकल कंडक्टर के लेफ्ट साइड में एक चार्ज Q है. तो इसके लिए हम लोग देखने वाले इस टू केस इज वेरी इंपॉर्टेंट. ओके, सो इन दिस लेक्चर्स in the course of method of images we have to cover these two important topics. Okay, one is for infinite conducting plane, another is for grounded spherical conductors. Okay, very good. So now next is the importance of a method of image. So in electrostatics, okay, in electrostatics, what is the importance of method of image? Why actually we have studies about method of image, right? So in electrostatics, problems involves conductor, okay, like grounded plane, spherical cavity, etc. These are the kind of conductor. Okay, so solving Poisson's and Laplace equations directly with boundary conditions is hard. Okay, so for that case, grounded plane, sphere and gravity, for that case solving the Poisson's and Laplace equations directly using boundary conditions is very hard. Okay, so the method of image is actually convert this into a simple point charge problems. Okay, so that's very important. So in that case grounded plane, sphere and cavity, for it kind of case the Laplace and Poisson's equations, using solving Laplace and Poisson's equation, find out the potential, electric field, charge density, etc. It's a very difficult problems, right? So we can find out that those properties like potential, electric field, charge density and total charge, Using method of image is very easy, because the method of image convert this in a simple point charge problems. Okay, next problems is helps to determine the induced charge distributions. Okay, and also allows computation of surface charge density, is also allows surface charge density, and it gives force on a charge due to a conductor via image charges. Okay, it means an image charge is produce an image charge of this real charge, and I can find out the force on a charge by this image charge actually. Okay, I mean, it is a infinite conducting plane. If at a distance d, at a distance d, there is a charge q. Okay, and this charge have a image charge at a same distance of minus d is minus q, and we are find out here the force on this plus q charge due to this image charge. So this is basically image charge. Okay, this is basically image charge. This is basically image charge, and this is basically real charge. So we can easily find out the force, and also enables computation of electrostatics pressure on this conductor. ये जो कंडक्टर है, इस कंडक्टर के ऊपर हम लोग इलेक्ट्रोस्टैटिक्स प्रेशर भी कैलकुलेट कर सकते हैं. दैट इज बेसिकली इलेक्ट्रोस्टैटिक्स कंडक्टर. ठीक है, इस कंडक्टर के ऊपर हम लोग प्रेशर भी हम लोग कैलकुलेट कर सकते हैं. दैट इज वेरी वेरी इंपॉर्टेंट. तो मेथड ऑफ इमेज के का जो मेथड ऑफ इमेज का जो कंसेप्ट है, इसी कंसेप्ट को यूज करके हम लोग इस तरह का प्रॉब्लम्स फाइंड कर सकते हैं. So this is the importance of method of image in electrostatics. Okay. Next, what kind of applications we are doing here actually? Okay, what kind of applications we are doing here? That is very very important. Okay. So if we talk about the applications part, let us take an problems basically. A charge applications mean charge above an infinite conducting plane. So take a infinite grounded planes actually. Okay, we are consider grounded conducting planes, that is grounded conducting planes. Okay, right, that is grounded conducting planes, and a charge plus q located at a distance d above. Okay, d above. This is the problem. So our main goal of this problem is find out the electrostatics potential in the regions above the planes. प्लेन के ऊपर में जो रीजियंस है उसमें हम लोग पोटेंशियल को कैलकुलेट करने वाले हैं. ठीक है, इलेक्ट्रोस्टैटिक्स पोटेंशियल को हम लोग कैलकुलेट करेंगे. राइट, इलेक्ट्रोस्टैटिक्स पोटेंशियल. नेक्स्ट हम लोग देखने वाले फाइंड द इलेक्ट्रिक फील्ड अबव द प्लेन, ऑल्सो इलेक्ट्रिक फील्ड अबव द प्लेन्स, एंड ऑल्सो इंड्यूस सरफेस चार्ज डेंसिटी ऑन द कंडक्टिंग सरफेस. ये जो कंडक्टिंग सरफेस है, ठीक है, ये जो कंडक्टिंग सरफेस है, इस कंडक्टिंग सरफेस में हम लोग इंड्यूस सरफेस चार्ज, कितना चार्ज इंड्यूस्ड हो रहा है वो हम लोग कैलकुलेट कर सकते हैं. नेक्स्ट, टोटल चार्ज इंड्यूस्ड ऑन द सरफेस, ऑल्सो कैलकुलेट द टोटल चार्ज इंड्यूस्ड ऑन द सरफेस. एंड नेक्स्ट हम लोग कैलकुलेट करने वाले कंप्यूट द फोर्स बिटवीन द प्लेन एंड द चार्ज. ओके, दैट इज वेरी वेरी इंपॉर्टेंट, फोर्स बिटवीन प्लेन एंड द चार्जेस, एंड कंप्यूट द electrostatics energy of the configurations. So these 6 cases I have to cover here. Okay, one by one I will cover. Okay, so next, find out the electrostatics potential in the regions above the planes actually. That is very very important case. So start here some pictorial views. So okay, yes, this is the conducting planes. Okay, and this is the center of these conducting planes. Consider the coordinate, this is O. Okay, this is the so above these conducting planes there will be charge plus Q at a distance t, right, at a distance t, right. So for that case you have to calculate the electrostatics potential in the regions above the plane. Okay, so let us consider the point P. This is the point P and the coordinate it x comma y comma z, and we have to calculate here the potentials actually. So okay, this is the distance. So the distance between charge plus Q2 is basically, this is the locations is 0 comma 0 comma d, and you know the concept, when a charge plus Q is placed above an infinite plane, then at the same distance from these planes, okay, so from the same distance from this plate there will be charge, opposite charge minus Q. Okay, minus Q is basically induced here. So this is the main concept here. So what I say, when a charge plus Q, okay, when a charge plus Q placed, okay, let us write, when a charge plus Q is placed at the above of the plane, then an image charge of minus Q is induced at a distance minus t. Okay, at a distance minus t. Okay, so the coordinate of charge Q plus charge Q coordinate is basically 0 comma 0 comma d, and the coordinate of minus charge is basically 0 comma 0 minus t. Okay, and let us consider the positions vectors. Let the positions vector of point P x comma y comma z from plus Q charge each R plus. Okay, so how can I calculate this R plus? So that is very important. Okay, how can I calculate this R plus? It's actually, that is very important. So the distance between 0 comma 0 comma d and x comma y comma z. So R plus is nothing but root under x square plus y square plus z minus d whole square. Okay, so this is basically R plus. Okay, this is equations 1. In the similar way, R minus, let us take, this is the coordinate, this is basically R minus. Okay, the distance between minus Q charge and the point where we want to calculate the potentials actually. Okay, so the positions vector of p x comma y comma z from charge minus q each r minus, and that is equals to distance between 0 comma 0 comma minus t and x comma y comma z. So in the similar way, x square plus y square plus z plus t whole square. So this is equations 1. Okay. So this is basically equation numbers 1. Okay. Now in our hand we have आप देखिए हम लोग के पास पोजीशंस वेक्टर, जिस पॉइंट में हम लोग पोटेंशियल को कैलकुलेट करना चाह रहे हैं उस पॉइंट पे पोजीशंस वेक्टर से, तो हम लोग पोटेंशियल कैलकुलेट करने वाले इस पी पॉइंट में. सो पोटेंशियल ड्यू टू दिस चार्ज क्यू. ओके, सो नाउ potential at p x comma y comma z due to charge plus q each b plus, that is equals to q upon 4 pi epsilon naught r plus, right? So that is equals to q upon 4 pi epsilon naught into 1 upon x square plus y square z minus t whole square. That is equation number 3. Okay, in the similar way potential at p x comma y comma z, okay, x comma y comma z due to charge minus q each b minus, that is equals to minus q upon 4 pi epsilon naught r minus. Okay, so that is equals to minus q upon 4 pi epsilon naught into 1 upon x square plus y square z plus d whole square. Okay, right. So now this, so I mean, so now we have two potential. One is for positive charge, one is for negative charge. But we want to calculate the net potential at the point P. Okay, so the net potential. So the net potential at point P x comma y comma z due to this charge, due to these configurations, okay, due to this configurations, V net is equals to V plus plus V minus. Okay, so V plus is nothing but Q upon 4 pi epsilon naught upon x square plus y square z minus t whole square minus Q upon 4 pi epsilon naught x square plus y square plus z plus d whole square. So this is nothing but V net, and this is equation number 4. So we get here the V net is equals to Q upon 4 pi epsilon naught into 1 upon x square plus y square plus z minus d whole square minus 1 upon x square plus y square plus Z plus D whole square. This is equation number 5. So this is the potential of these configurations at above the planes. Okay, right? So this is the potential. This is the potential of these configurations above the plane. Okay, at one thing, so we are already there have a grounded conducting planes. This is the origins. This is the point charge Q located at 0, 0, D, and this is the point located minus Q charge, and the coordinate is 0, 0, minus D. And we calculate at the point P x, y, z, and here is the potential is V net. We already calculate. But now my question is, what is the potential at this at these locations V z equals to 0? That means potential where the plane is basically located. Okay, so this is the coordinate 0, 0, z, 0. So at that point, what is the value of this potential? So H, the infinite conducting plane, is grounded, hence potential at z equals to 0 is V of 0, 0, z equals to 0 is equals to 0. So that is very, very important. Okay, and also potential below this conducting plane at V equals to 0, 0, z equals to minus D is also 0. Okay, below this conducting planes is equals to 0. Okay, so this is the case. In this way we can find out the potential from this conducting planes. I mean for this configurations actually. तो आप लोगों के पास इस तरह का कन्फिगरेशन होगा, तो इस तरह का कन्फिगरेशन के लिए लोग आराम से इलेक्ट्रोस्टैटिक्स पोटेंशियल आप लोग कैलकुलेट कर सकते हैं. तो प्लेन के ऊपर हम लोग पोटेंशियल कैलकुलेट करना है, तो जो वी नेट का कैलकुलेशन जैसा हम लोगों ने किया उसी तरह हम लोगों को कैलकुलेट करना होगा. बट ऑन द प्लेन के ऊपर पोटेंशियल 0 है, प्लेन के नीचे पोटेंशियल भी 0 है. ओके, तो इस कंसेप्ट को अच्छे से तुमको याद रखना होगा. ओके ओके, नेक्स्ट गो टू द very good points. It's actually 1 second. Yes, okay, so we calculate the electrostatics potentials. Yes, so we can find out the electrostatics potentials actually above the planes, below the planes, and on the planes. So you can write here, this is the conducting plane, this So the conducting planes, okay, and here just charge is located, and here charge, opposite charge minus q is located. So potential above the planes, okay, p of potential above the planes, that is equals to q upon 4 pi epsilon naught 1 by r plus minus 1 by r minus, okay. Now potential on the plane is 0, below is also 0. So these are the very important case I have to cover here. I have covered here actually. So इस तरह का केस को आराम से समझना चाहिए. आर प्लस क्या है, आर माइनस क्या है, ऑलरेडी मैंने यहाँ पे डिस्कशंस किया. कैसे तुमको एक एक चीज़ को कैलकुलेशंस करना है ये हम लोगों ने देखा एक्चुअली. ठीक है. नेक्स्ट वी आर गोइंग टू फाइंड आउट the electric field above the planes. Okay, electric field above the planes we want to calculate here, above the planes actually. Okay, so as we know, electric field E vectors is equals to grad of V, right? So electric field above is equals to minus gradient of V above. Electric field below, that is equals to gradient of V below. So as V below is 0, so that is equals to obviously 0. So electric field below this plane is must be 0, right? It must be 0. But above the planes there is some value, right? And now we are going to here this calculate this value. What is the value? How can I calculate actually? Okay, so now E vectors above is equals to gradient of V above. So that is equals to minus del z, because V above is only changed by these z vectors. X and y are constant. Okay, x and y are basically here constant. Okay, constant. If I change the value of z, then the potential value is also changed, right? So potential is changed along z directions only. Okay, so that is equals to V above into z cap. Okay, so here write E vectors will be in the z cap directions because x and y axis are infinite. Okay, that is very important. X and y axis are infinite. Okay, right. So already we have calculated V above. Put this value. So minus del z q upon 4 pi epsilon naught x square plus y square plus z minus d whole square minus q 4 pi epsilon naught, okay, 4 pi epsilon naught root under x square plus y square z plus d whole square into z. Okay, let's just, it's a very basic derivative. Okay, let's do it. 1 by 1. So minus q upon 4 pi epsilon naught is taken out of this bracket, and now minus half x square plus y square plus z minus d whole square whole to the power minus 3 by 2. Okay, and plus half okay, it's very good, and for this into 2z minus 2d, 2z minus 2d plus half x square plus y square plus z plus d whole square minus 3 into 2z plus 2d. It is a very basic derivative. Okay, now just take common, so minus plus q upon 4 pi epsilon naught z minus d upon x square plus y square z minus d whole square whole to the power plus 3 minus, obviously minus z plus d upon x square plus y square plus z plus d whole square whole to the power 3 to z cap. So this is the electric field at a JEST distance above the plane. Okay, so this is the electric field at a JEST distance above the plane, and below the plane electric field is 0. We already discussed this. Okay, below the plane electric field is 0 because potential is also 0. That's why electric field also 0. So this is the way we can calculate the electric field as well as potential. So first of all, you can calculate potential, and then you can use Poisson's equations, E equals to minus grad phi. I mean the basic relationship between electric field and potential, and use these relations, and you can calculate the electric field also above the planes, right? Okay, next we are going to discuss a very important part, that is induced surface charge density on the conducting surface. So again, let us draw a diagram. Basically, let's draw a diagram. Okay, that is the point the image charge is basically located, and this is the point where real charge q is located, and we want to calculate here how many charge density is induced basically on the conducting planes. ये जो conducting plane है इसके ऊपर कितना चार्ज डेंसिटी बेसिकली इंड्यूस्ड हो रहा है, हम लोगों को कैलकुलेट करना है बेसिकली. तो इंड्यूस्ड चार्ज डेंसिटी कैलकुलेट करने के लिए बेसिकली सरफेस चार्ज डेंसिटी होगा प्लेन के ऊपर कितने अमाउंट ऑफ चार्ज बेसिकली चार्ज सरफेस चार्ज डेंसिटी बेसिकली मेनली हम लोग कैलकुलेट करने वाले सरफेस चार्ज डेंसिटी. तो सरफेस चार्ज डेंसिटी कैलकुलेट करने के लिए वी नो ए वेरी इंपॉर्टेंट फेमस रिलेशंस. What is the famous relations? That is nothing but delta V above minus del n. Del n is basically perpendicular directions of this plane, perpendicular directions of the surface. Basically, in here is nothing but perpendicular directions in this plane. Equals to minus sigma upon epsilon naught. So n here is the perpendicular directions of the surface, for that case plane. So n is nothing but here z cap. So n cap is nothing but z cap. So we can write these expressions like del p above del z minus p below upon del z minus sigma induced upon epsilon naught. So as we already know, delta v below is 0. Okay, so this part will be going to 0. So now sigma induced upon epsilon equals to minus del v above upon del z. Okay, del v above is to del z. Okay, this is the expressions we use here. But we want to calculate induced surface density on the conducting surface. So induced surface, so that is basically, one second. So we want to calculate the induced surface charge density on the conducting surface. It means at z equals to 0. It means at z equals to 0. Okay, on the conducting surface, it means at z equals to 0. So we want to calculate sigma induced is equals to minus epsilon naught above upon del z at z equals to 0. We want to calculate this actually. Okay, very good. Now sigma induced is equals to minus epsilon naught del z v above, that is equals to q upon 4 pi epsilon naught x square plus y square z minus d whole square minus q upon 4 pi epsilon naught, that is equals to x square plus y square z plus d whole square at z equals to 0. Okay, so minus epsilon naught, and that is equals to, okay, q upon 4 pi epsilon naught minus half 2z minus 2d upon x square plus y square plus z minus d whole square whole to the power 3 plus half 2z plus 2d upon x square plus y square z plus d whole square whole to the power 3 at z equals to 0. So when put z equals to 0, that is equals to minus q epsilon naught upon 4 pi epsilon naught, that is equals to minus plus d upon x square plus y square plus d square whole to the power 2 plus okay, this is minus actually, this is minus minus up minus minus plus, yes, this is actually plus up, yes, okay, plus d upon x square plus y square into d square whole to the power 3, yes, that is the expressions, right? So induced charge, total induced charge is nothing but here epsilon naught cancel each others, okay, so that is equals to minus 2qd upon 4 pi sorry, x square plus y square plus d square whole to the power 3, so final answer is nothing but minus qd upon 2 pi x square plus y square plus d square whole to the power 3. So this is the induced charge, okay, this is the induced charge, okay, so this is the induced charge. So one thing you remember, the induced charge is a non-uniform and negative. So you remember here one very important concept, okay, one very important concept. So the induced charge, sigma induced is nothing but qd upon 2 pi x square plus y square plus d square whole to the power 3. So from these expressions we can easily say that is this induced charge is non-uniform, okay, non-uniform, and the second point is negative. So induced charge is non-uniform and negative, so it's very important, okay. So this is the way can calculate the induced charge on this surface, I mean at z equals to 0, at z equals to 0, I mean on the infinite conducting planes, right? Okay. Next we are going to calculate the total charge on the surface. Total charge. So we already know the induced charge on the surface. Next we want to calculate the total charge on the surface. Right. So we already know Q induced. Right. We already know Q induced. So Q induced at z equals to 0. At z equals to 0 is nothing but qd upon 2 pi x square plus y square plus d square whole to the power 3. We use this result to calculate the total induced charge. So total induced charge q prime is equals to integrations sigma surface integrations into d, surface integrations. So we take a surface integrations. So now we have to convert this Cartesian coordinate into spherical polar coordinate systems. So now we have to convert Cartesian coordinate into spherical polar coordinate system. Spherical polar coordinate systems. Okay, so we have a r vectors for on the planes. Actually we know the r vectors x I cap, y j cap, and r square is nothing but x square plus y square, we already know. So dA is nothing but ds theta, so that is equals to r dr d phi, because theta is constant here. Theta is constant here, okay, because theta is constant here. So okay, we use these expressions. Now we use this expression. So q prime is equals to surface integrations for r 0 to infinity. Why take it r 0 to infinity? Because the plane is the infinite planes, x and y. X is infinity, y is also infinity, so r is also infinity, 0 to infinity. Okay, so that's why 0 to infinity, because we are calculating the surface integrations throughout the planes, actually along the surface, that's why. And the next is phi, so 0 to 2 pi, and sigma r dr d phi. Okay, so okay, very good. So phi integrations is give you 2 pi, so 0 to infinity sigma r dr, okay, 2 pi 0 to infinity. Sigma is basically minus d upon 2 pi, okay, x square plus y square plus t square whole to the power 3/2 r dr. So we are already know x square plus y square is nothing but r square. We put here, okay, we put here. So 2 pi cancel each other, minus qd taken out of these integrations, so 0 to infinity r dr upon r square plus t square whole to the power 3/2. Okay, so let us take r square plus d square is equals to t, so 2r dr equals to dt, so r dr is equals to dt by 2. Okay, let's put here. So minus qd 0 to infinity r dr is nothing but dt by 2, okay, dt by 2 into t to the power 3/2. Okay, okay, very good. So now the integrations is equals to minus qd upon 2, and that is equals to t to the power minus half t to the power minus half and minus half. So half cancel each others, minus cancel each others, and that is basically 0 to so basically 0 to infinity. So r square 0, okay, when take it 0, basically d to infinity, right? So d to infinity. d to infinity. Yes, it is basically d to infinity. Yes, d to infinity when r equals to 0 basically here. So t equals to d square. T is equal to d square. So d square to infinity. Yes, this is basically d square to infinity. This kind of case. Okay. So now just substitute this all this value. So q prime is equals to minus q. Q prime is equals to minus q. So we get here the induced charge on this plane. So this is the induced charge on this plane. The amount is same, only the opposite charge is actually induced here. Okay, so please remember this concept here. So that is very important. Opposite charge is actually induced here, right? Okay, this is a very good concept. Okay, next we're going to discuss the electrostatics force on this charge. Okay, electrostatics force on this charge. So electrostatics force. So basically we want to calculate here, this is the conducting plane and here the charge plus q is located and the coordinate is 0, 0, d and an image charge is produced at a distance 0, 0, minus 2 and the charge is basically opposite sign of this real charge. Image charge is basically opposite sign, opposite charge. If real charge is negative, then image charge is positive, and if real charge is positive, then image charge is negative. This is the case. So now we have to calculate the force on this charge, actually force on this real charge. So the direction of force is towards the negative charges. Mathematically, the image of plus q is minus q. Yes, and this image charge will attract this charge, but practically the surface is attracts, is basically charge induced on the surface. Okay, the surface attracts this charge, so it hence the electrostatics force on this charge is basically 1 by 4 pi epsilon naught q upon 4d square, because the distance between these two charges is basically 4d 2d. Distance between is 2d basically. Okay, distance is basically, this is d and this is also d, so distance between these two charges is basically 2d. Okay, and the force direction is along the direction of minus charge. Okay, so that is the expressions of electrostatics force on this charge. So please remember this case. So directions of this force is along the image charge, right? Along the image charge basically. Okay, that is a very important concept. Next we want to calculate the electrostatics energy of these configurations. जो configuration already हम लोगों ने बात किया उसके ऊपर, electrostatics energy. So what is the meaning of this? So basically what is the meaning of this energy? Work done to bring a charge plus q from infinity to a point on the surface O. जो प्लेन का पॉइंट, प्लेन का जो मिड पॉइंट है, उस ओ पॉइंट में तुम इन्फिनिटी से एक चार्ज को उस पॉइंट तक, if I want to bring a charge q from infinity to this point, then how much amount of work done is how much amount of work is needed to bring this charge? So this is basically nothing but is energy. So force is not a variable along x and y directions, so it is variable along z directions only, because x and y is infinity. So the variable force is nothing but this is, and if I write is vectorial directions, that is z cap. So it's the variable force. Now so we need to calculate the work done to infinity to a distance d. Okay, need to work done. So the work done is nothing but w equals to infinity to d f dot dr. So this work done will be stored in the form of energy, especially as a electrostatics energy. So this is the expressions to calculate the electrostatics energy of these configurations. Okay, so now we are going to calculate the electrostatics energy. Okay, so electrostatics energy w is equals to infinity to d f dot dr. Okay, so that is equals to infinity to d 1 by 4 pi epsilon naught q square upon 4 z square. Yes, 4 z square into dr is nothing but dz. Okay, so that is equals to 1 by 4 pi epsilon naught q square upon 4 pi epsilon naught into 1 by 4 infinity to d and dz upon z square. Okay, so that is equals to q square upon 16 pi epsilon naught minus 1 by z into infinity to d. So that is equals to q square upon 16 pi epsilon naught minus 1 by d plus infinity. So the energy is nothing but q square upon 16 pi epsilon naught d. Q square upon 16 pi epsilon naught d. So this is the electrostatics energy of this configurations 16 pi epsilon naught. Okay, and this work done, this is nothing but work done, and this work done is stored as a electrostatics energy from these configurations. So this is the whole theory for infinite conducting planes. I basically discuss here one by one. So if I say in as a summary, so you have a conducting plane, okay, and you want to calculate the electrostatics potential, and and you get electrostatics potential from above the planes and also electric field above the planes, and you can calculate, and then you can calculate using the concept, use the value of this potential above the planes, the induced surface charge density on the planes as well as the total charge induced on the planes. Okay, and next, and along with that, you can calculate the electrostatics force on the real charge by this image charge, and also you can calculate the electrostatics energy of these configurations is actually, okay, electrostatics energies of these configurations. I mean, you want to bring a charge from infinity to this plane, so then what amount of work done is needed to bring this charge from infinity to this point? So that is nothing but the electrostatics energy here, I mean for these configurations actually. Okay, so these are the basic problems here we can deal using this image method of image concept of this infinite planes actually. So these all are very very important. In the next class I am going to discuss some problems, some very very important problems, some theoretical background related problems, and then I'm going to discuss each of the problems like TIFR, JEST, and etc etc etc. So these are the these 6 problems are very very important, so you need to understand it very well. So I hope you understand each of this concept. So if anyone have any kinds of doubt, so please put a message, put a comment in my YouTube channels, so I definitely give you some feedback. Okay, so in the okay, yes, this is the very important lectures, and I hope you enjoy these lectures. So okay, thank you, and thank you for watching this video.